So for final approximate circuit, final approximation, we will ignore the shunt branch completely, right? So for all practical purposes, the terminal voltage is always maintained at the nameplate value unless otherwise stated, right? So without any appreciable change in efficiency, you can ignore the shunt branch completely, right? Because magnetizing current is hardly 2% to 6% of the full load current, right? So I'm ignoring the shunt branch completely. So the circuit becomes simply like this. It will look like this. So this is R1 equivalent, this is X1, J times of X1 equivalent, this is V2 dash, this is V2 dash, right? This is V2 dash, right? V2 dash, and here this is I1 is equal to I2 dash. After ignoring the shunt branch, this is I2 dash. I2 dash will be equal to I1. This is V1, right? V1. So V1 is not rated voltage, right? V1 is not rated voltage. Yes. V2 dash is the rated voltage. V2 dash and V2 are the rated voltages, right? So I0 is 2% to 6% of the full load current. So that's why we have ignored the shunt branch, right? So if you make phasor of this, then you can simply make it like this. Take V2 dash as a reference phasor, draw it horizontally at 0 angle. Then for lagging power factor, you have to, this is obviously lagging because inductor, right? This is inductive circuit, right? So current will be lagging by the voltage. So from V2 dash, I2 dash is lagging by angle phi 2 dash. So I1 is equal to I2 dash, V2 dash. Now to show the drop I2 dash R1 equivalent or I1 into R1 equivalent in phase with I2 dash, you have to make this. Now at 90 degree ahead of this, you will make anti-clockwise. Ahead of this, you will make J1 X1 equivalent. Take phasor sum of all these three, you will get V1 dash. V1, right? V1. Now voltage regulation. What is voltage regulation? Voltage regulation is basically, it is rise in output voltage expressed as a fraction of full load rated voltage when full load is removed, keeping input voltage constant. So voltage regulation is V no load minus V full load divided by V full load. So no load voltage minus full load voltage divided by full load voltage per unit, right? There is no unit, so that's why we will write per unit, right? Because it's a ratio, right? So in denominator, you keep in mind it is full load voltage, right? VFL in denominator, and it is not VNL. So VNL is not there, no load is not there in denominator, it is full load. So voltage regulation is always calculated with respect to full load, right? Consumer bothers only for full load, right? Consumers does not bother whether what is the voltage, what is the change in voltage at no load, right? Consumer will see that after applying full load, what is the drop in voltage. He is concerned with that, right? फुल लोड लगाने पे वोल्टेज कितना गिरा, कंज्यूमर को इससे मतलब है, ना कि इससे कि नो लोड पर वोल्टेज कितना है, राइट? So we will always take voltage regulation with respect to full load. So in denominator we will write V full load. So voltage regulation is equal to V no load by V full load divided minus 1. So voltage regulation is V no load per unit minus 1. So where full load voltage is equal to rated voltage, right? Or you can say nameplate voltage, right? So full load voltage is equal to rated or nameplate voltage. Nameplate values are rated values, right? Right. So voltage regulation means full load regulation, and not the no load regulation, right? So at the nameplate, the voltage that you see, it is for output, right, and not for the input, right? So now you see this numerical that will further clarify this. So here the transformer, the question is like transformer has equivalent impedance of 0.01 plus j.1. Now calculate voltage regulation at 0.8 power factor lagging. Second part at unity power factor lagging. Third part 0.8 power factor leading. These are the three parts you will have to calculate voltage regulation at different power factor, right? So take part 1. So V1 is equal to V2 dash plus I1 Z1 equivalent from the equivalent circuit, approximate equivalent circuit. From this you can write V1 is equal to I1 Z1 equivalent plus V2 dash. From this circuit apply KVL and you will get this equation, right? So here V1 is equal to V2 dash plus I1 Z1 equivalent. So V1 is equal to V2 dash. It is for rated value. You have to take it per unit, right? So 1 per unit means 100%. That is 1 angle 0, right? It is taken as reference. So angle 0. So here plus 1 angle minus of cos inverse 0.8, because in first part you will have to calculate voltage regulation at 0.8 power factor. So lagging means negative sign. So minus cos 0.8, cos inverse 0.8. Now Z1 equivalent is 0.01 into 0.j1, right? So it is basically per unit. It is given in per unit and not in ohms. Mind it very clear, right? So you write this per unit 0.01 plus j.1. So you calculate it and you will get 1.0706 angle 3.96 per unit, right? So hence voltage regulation is come out to be equal to V1 per unit minus 1. So take magnitude. So 1.0706 minus 1. So 7.06% will be the voltage regulation. So this much voltage will vary, change, right? This much voltage, around 7% voltage will change at 0.8 power factor lagging. Now second part at unity power factor. Second part at unity power factor you will have to calculate. So repeat the same process at unity power factor, right? Now here one thing you note down, that V2 dash is basically output terminal referred to primary side. Output terminal voltage. V2 dash is output terminal voltage referred to primary side, right? Primary side. So here rated voltage is V2 dash, that is 1 per unit and not V1. Mind it very clear. Rated voltage is V2 dash. This is V2 dash. V2 dash, that is 1 per unit and not V1. V1 is not rated voltage, right? So in part 2 you will have to calculate at unity power factor. So V1 is equal to V2 dash plus I1 Z1 equivalent. Again the same formula. V1 1 angle 0 plus I1 into Z1 equivalent. So now current I1 is, you see it is at unity power factor, and for the rated current it is 100%. So 1. Now at unity power factor angle is 0. Cos 0 is 1 because cos 0 1, right? So for unity power factor rated current it is 1 angle 0. I1 is 1 angle 0. So that is the expression. Now Z1 equivalent 0.01 plus j.1, that is given, right? So you solve this, you will get 1.0149 angle 5.65. 1.0149 angle 5.65 per unit. Now voltage regulation, you take magnitude of V1. So 1.0149 minus 1, so it is 0.0149, so 1.49%. So at unity power factor you see that there is some less change in voltage, around 1.5%, that is exactly 1.49%, right? Now part 3 is 0.4 power factor leading. So now at this power factor 0.4 power factor leading, part 3, V1 is equal to V2 dash plus I1 Z1 equivalent. Same equation you apply. So V1 is 1 angle 0, V2 dash is 1 angle 0, right? It is taken as reference, I told you. So I1 is now, it is rated with angle 0.4 power factor lagging. At this you will have to calculate 0.4 power factor leading. It is now leading, right? It is now now it is leading power factor, that is 0.4 leading and not the lagging or unity. So at this power factor you write one angle plus, for leading you write plus cos inverse 0.4, right, because current is leading the voltage, so plus. So plus cos inverse 0.4 into Z1, that is 0.01 plus 0.1J. So you get here the point V1 is 0.9137 angle 3.0 per unit. So now voltage regulation is 0.9137, 0.9137 minus 1. So here minus 0.0863 per unit, that is minus 8.63. So you see that at leading power factor you get negative voltage regulation, right? So at a leading power factor you keep in mind that voltage regulation may become leading, also may become negative, right? So negative voltage regulation you will get only at leading power factor, right? So minus 8.63 is the answer at leading power factor. So voltage regulation, it may be negative at leading power factor, right? So that means like that we will have to calculate, right? So that was a question. Okay, so thank you very much, thanks for watching.